5x minus 9 over x plus 1 is less than or equal to x minus 3. So let's break it into these half-line segments then. The first one we can look at is x plus 1 is greater than 0. So when x plus 1 is greater than 0, then that means x is greater than minus 1, isn't it? So this is positive, so we can swing it up. So we get 5x minus 9. It doesn't change the inequality, does it? Because it's positive. So move that up. We get 5x minus 9 then is less than or equal to, expand the bracket, x squared plus minus 3 plus 1 minus 3 is minus 2x. And then minus times a plus is a minus, 3 ones are 3. So read from right to left then, x squared. Move the 5x to be with the 2x. So minus 5 minus 2 is minus 7 lots of x. 9 minus 9 moves across to be plus 9. Take 3 is 6. We're all over this side, so reading from right to left is greater than or equal to 0. Factorise, which we hope it does. 6 and 1 minus and a minus is greater than or equal to 0. So let's draw this quadratic then. It's got roots at 6 and 1. And it's a positive U-shaped curve because it's got an x squared, hasn't it? So here it is here. When is this greater than 0? Well, it's greater than 0 when x is greater than or equal to 6, and also when x is less than or equal to 1. We can see that from the sketch. Now we're talking about the context of x being bigger than minus 1. There's minus 1 and it's bigger. So there's the context of our discussion, and we found a solutions set of x bigger than 6, which is entirely fine. So x bigger than or equal to 6 is entirely fine. Or the other solutions we've got here are when x is less than 1 or equal to 1, but in the context of it being bigger than minus 1. So let's put that down as well. There we go. So there's our solutions in this first part of the problem. Now let's look at the second part of the problem. So that would be when x plus 1 is less than 0. In other words, x is less than minus 1. In this case, when this moves up, we'll have exactly the same terms, but this will flip because it's negative. So if we can write the same thing down then. So here we've got x plus 1 times x minus 6, and this time this has been flipped around, hasn't it, in the algebra. So it's less than or equal to 0. So when is this less than or equal to 0? Well, we can see from the graph that it's negative, less than or equal to 0 when x can go up to 6 and include 6 because it can equal 0, and can go down to and include 1. That's our solution set, but the context of our problem, that was meant to be a full stop, wasn't it? Was x is less than minus 1, and there's no overlap with this solution set that we found. So no solutions in this case. Consequently then, we can just finally collate these entire solutions set, and we've seen that x can be bigger than or equal to 6, or minus 1 is less than x is less than or equal to 1.